Alright, so now we're on to the polar equations of conics, and that chart with the different pictures is going to be really important. On 25 and 26, find the polar equation of the conic with focus at the pole, which all of these have a focus at the pole, and then it gives us some properties, and it asks us to identify the conics. So there's a little thing in our notes at the beginning of 8.5 that tells us how to tell between the three, and if you haven't written it on your graphic organizer, you should. If our eccentricity is 1, that means that we've got a parabola. Okay, and then that also tells us what E is in our formula. If the directrix is x equals 4, you look at A, B, C, and D, and you look for the one that has x equals a positive number, which is A. So our answer is going to be of the form R equals KE over 1 plus E cosine theta. And K is 4, E is 1, so we just plug that stuff in. So 4 times 1 is 4 on top. 1 plus 1 cosine theta is just 1 plus cosine theta. Since we don't have any pesky fractions on top or bottom, that's good to go. Now, this one, our eccentricity is 3, so if E is bigger than 1, that's a hyperbola. And then K has to be 4, and you're looking for the letter choice that has x equals a negative k, which is B. So our equation has to be R equals KE over 1 minus E cosine theta in this case. So R equals negative 4, actually K is just positive 4. So R equals 4 times 3, which is 12, over 1 minus E, which is 3 cosine theta. Now, this didn't happen on either of these problems, but it could happen on the test, but over here on the side, I'm just going to work this out really quick. If you end up with something like this, like remember that if we multiply everything by 2 and get rid of that fraction, that's okay. So we would simplify this and make this be 5 over 2 plus 1 cosine theta, okay? So keep that in mind, because we're about to do the opposite of that on 27, 28, because to determine the eccentricity, which is E, the type of conic, and the directrix, which has to do with K, we have to first get this in standard form, which means that this has to be a 1, right here where 9 is. And to make that be a 1, it's really simple. We're just going to divide it by 9. But to do that, we have to divide everything by 9. So that this becomes R equals 4 over 9 over 1 minus 5 over 9 cosine theta. But the beauty of that is it tells us that E is 5/9, and that KE, which is the top, equals 4/9. Also, no, never mind, not also. Keep going. So if E is 5/9, we can plug it in right here. And multiply by the reciprocal 9/5 and get K equals 4/5. So K has to do with our directrix. We found E. This is an ellipse because that number is less than 1. And then K is 4/5. Since this is negative cosine, look at your directrix. That's x equals negative k. So x equals negative 4 over 5. This one we need to divide everything by 2. So R equals 1/2 over 1 plus 7/2 sine theta. So E is 7/2, which gives us a hyperbola because it's bigger than 1. And then for KE is 1/2, but we know that E is 7/2. So you multiply by the reciprocal, which is 2/7, and that gives you K equals 1/7. That means that our directrix, since this is a plus sign on the bottom, our directrix is y equals k, so y equals 1/7. Alright, 29 and 30, finding the polar equation given basically 2 points that these are polar coordinates, remember, so they're r theta, not xy. These can be kind of tricky. I find it helpful personally to draw a picture, and the more familiar you are with the parts of these conic sections, the easier having a picture will make it. So at 0 degrees, we are 5 out from 0, 0, and at pi, which is this direction, we're 3 out. And so our ellipse is looking something like this. So that tells us a few things. This point right here, remember that 0, 0 is one of our foci. And we look just at this part of my graph, this left side of the graph, to match up what our standard form of our equation is going to be. This is going to be b, which is r equals ke over 1 minus e cosine theta. And if you pick a different one, chances are something terrible could happen, and so you might notice pretty quickly that you picked the wrong one. So if I'm looking at this picture, this is a pretty nice picture. All the way across here from vertex to vertex is 8, right? So 2a equals 8, which means a equals 4. And then if I find c as well, that will give me e, because e equals c over a. So if a is 4, that means the center of our ellipse is right here. C is always the distance from the center to a focus, which in this case is 1. So e equals 1 over 4. Now to find k, the only thing we can really do is plug in one of these 2 points into our equation, but we already know what e is, so that's going to help us in the long run. Otherwise, we would have to plug in both points and end up with a system of equations. So I'm just going to pick the first one and plug in 5. So r is 5 equals k times e, which is a fourth, over 1 minus 1/4 cosine 0. So here's where you should know if you messed up. Cosine of 0 is 1, so it'll go away, and that should typically happen like a lot. So 5 equals 1/4 k over 1 minus 1/4 is 3/4. So we can flip this fraction up, or we can multiply the other side by it. Whatever makes you more comfortable. I'm going to flip it up and multiply by 4/3, which gets rid of these 4's and gives me 5 equals 1/3 k. So you multiply both sides by 3 and get k equals 15. So now I can write my equation. R equals k times e. So 15 times 4, which is 15/4, over 1 minus 1/4 cosine theta. And then finally we have to multiply everything by 4. I think this was the thing that didn't happen earlier on a problem that I tried to illustrate. Multiply everything here by 4 to get rid of our fraction. So that puts 15 over 4 minus cosine theta. Minus 1 cosine theta, which is just cosine theta. So that's our answer right there. Now for a hyperbola, we're going to go ahead and draw this, and then what happens here is, besides my drawing there, is kind of interesting. So at pi over 2, which is 90 degrees, we go up 2, and that's where one of our dots is. But at 3 pi over 2, which is straight down, we're going to go negative 14, which means we actually go this way, 14. So that puts it right here. These are our vertices. So this is where our hyperbola is, like this. And if we were drawing it ourselves by hand, this is where the end of our box would be. And we actually don't really know how wide our box is, have no way of knowing it at the moment. I guess we could find out if we wanted to, but we don't really need to. So remember that this point right here is a focus. And if we look just at the bottom part of this graph, this looks like part C. R equals ke over 1 plus e sine theta. So we can figure out We can do what we did on this previous problem, and that's fine, but let me show you the other way of doing this, where we just plug in both points. You can plug in r is 2 equals ke over 1 plus e sine of pi over 2, and you can plug in negative 14 equals ke over 1 plus e sine 3 pi over 2. This one gives you a positive 1, so that's just 2 equals ke over 1 plus e. This one gives you a negative 1, so that's negative 14 equals ke over 1 minus e. Sine of 3 pi over 2 is negative 1. And then you would solve this system of equations by like multiplying 1 plus e over here and multiplying 1 minus e over here. Now these both equal ke, so we can just set them equal to each other, and I'll distribute at the same time. Or we don't have to actually distribute. So you subtract 2e and add 14 and get 16 equals 12e, so e is 16 over 12, which is 4/3. And then you can plug that back in somewhere up here and get k. So this does seem like the slightly longer way of doing it. If you wanted to, you could do this the exact same way that we did the previous problem, and you should get the same answer. And so if you don't, that's probably a issue with the a's and the c's with a hyperbola instead of an ellipse. Alright, so this is 7/3 times 2, which is 14/3, equals k times 4 over 3. So you multiply both sides by 3 over 4. And get 14 over 4, which is 7/2. And that means that our equation is r equals 4/3 times 7/2, which is 28 over 6, which is 14 over 3, over 1 plus 4/3 sine theta, which you multiply everything by 3 and get r equals 14 over 3 plus 4 sine theta. So I've decided I like the first way better, as long as it's something that's easy to work with as far as graphing it goes. If you end up with like decimals and stuff, that can be a little trickier. So 31, find the values of E, A, B, and C. So we need to start off by getting this in standard form by dividing everything by what is going to make this be a 1 instead of a 5. So divide everything by 5. That tells us what E is. E is 2/5. That may or may not actually tell us what C and A are. C could be 2, A could be 5, but it could actually end up that it's like 4/10 or something else. So what you should do is go on your calculator, change the mode to polar and radian, and do our original equation, 21 over 5 minus 2 cosine theta. You can do the one we changed if you want to, but I just prefer the original one that has slightly less fractions. When you graph that, you may need to zoom standard to get it to look right, but if you look at that, you should see that we've got a point out here at -3 if we were in xy, and then 1, 2, 3, 4, 5, 6, 7 this other direction. And then here's our ellipse. Well, that means that between our vertices is 10, so A is 5, so C is 2. And that's just a quick way of checking to make sure that you really have A and C. If we have A and C, we can use the Pythagorean Theorem to find B. So A squared plus B squared This is an ellipse, so it's not plus, it's minus b squared. So a squared minus b squared equals c squared. So I subtract 4 over and add b squared over and get b squared equals 21, which means b equals the square root of 21. So that's all of the things they asked us for. I have a very small amount of space here. All right, so I'm going to go ahead and type this into my graph real quick. Looks like an ellipse again. Not that that's a bad thing. I said it like it was a bad thing, but it's not. But it does look like you're going to have to adjust your window by making your y-min something like maybe -15 so you can see the whole thing. To find e, we would divide everything by 4. And that will give us 1/2 for e. And so this is the case where c could be 1, a could be 2, but it's probably not. So look at your graph. We would go up 4. There's the top, and then down. Now that's kind of hard to count. So one thing you can do on this is you can press trace, and straight down is 3 pi over 2. So you can type 3 pi over 2, and it should have a theta equals if you pressed trace on your graph. And when you press enter, it should tell you that at 3 pi over 2, which it changes to 4.7 blah blah blah, that's at -12 for y. So in case you have problems counting or want to be safe rather than sorry, that's there to help. So that means that it's 16 all the way across. So a is 8 because it's half of what is all the way across here. If a is 8 and c over 8 is supposed to be 1/2 because e is 1/2, that means that c has to be 4, which you can cross multiply and find that. Now that we have a and c, we just need to Pythagorean Theorem it up. 8 squared is 64 minus b squared equals c squared, which is 16. 64 minus 16 is 48, I think. Yeah, 48. So b squared is 48. When I square root that, I get b equals 4 square roots of 3. So that's all there is to that, folks.